All right, so I just looked at the first part that I did, and I learned that the zooming in and out doesn't show up on the video. So I'm going to have to figure that out. But you can actually see these up close when you come back to school. So hopefully, especially lining these pieces up might be a little bit tricky to do. Okay, but we can sort it out. So now what do we have here? What we have here is called a right triangle. We're going to make a mark on this angle. And what does that mean? Well, when we put that mark there, it means that's a right angle. Remember our definition of an angle. An angle is made up of two rays that have a common endpoint. And those rays are called the sides of the angle. So we're going to call one side of the angle A, and we're going to call the other side of the angle B. All right, and so I'm going to make a little note here. A and B are called legs. They are the sides of the right, and by right we mean 90 degrees, okay? So A and B are called legs. These are the legs. These segments are legs. They are the sides of the right meaning 90-degree angle. And so now we've got another side of the triangle. We're going to label that C. And what's that side called? Do you know? I'll give you a minute to think. You can pause the lesson, see if you know the answer. Okay. C is called the hypotenuse. Hypotenuse. It's the longest side of the right triangle. The right triangle. And it's opposite the right angle. So if you look at these three sides of this triangle, these are the legs. They share a point with the angle. They are part of this angle, right? C is not. C is not part of this angle. It has nothing to do with this angle. It's opposite that angle, okay? All right. So you can pause the video to write that down, but fortunately I can just move on so this won't take so long. Up here, what I want you to write is I want you to write the Pythagorean theorem. Oh, but I almost blew the punchline, and I don't want to do that yet. So now you have to take a minute and look at this and try to see if you can recognize how A, B, and C are related in this case. Okay, this is an example of a right triangle. How are A, B, and C related? So I want you to pause the lesson and think about it. Okay, because once I tell you, it's spoiled forever. So pause the lesson and think about how are A, B, and C related. Okay, now I'm going to tell you, spoiler alert, spoiler alert. All right, so in this case, A squared, so this area is A squared. We can write a little A squared there. 3 by 3 is A squared. Here we have B squared, 4 by 4, B squared. And how many do we have in A squared? A squared is 9. b squared is 4 by 4, which is 16. And what does 9 plus 16 equal? Well, it equals 25. And what do we have here? Here we have 25. So c squared equals 25. Okay? So this side, if we count up these squares, put them into this grid, fill up this grid. So a squared plus b squared equals c squared. That's the relationship of the Pythagorean theorem. And this is the way we write it in geometry class. The sum, and sum just means, in this case, two things added together, of the square of the legs. So what we're really doing is we're squaring the length of the legs here, equals the square of the hypotenuse. Okay? The sum of the square of the legs equals the square of the hypotenuse. And the way we usually write that is a squared plus b squared equals c squared. And I want you to write that. I want to make sure you write it over here because remember we're going to have a pocket thing going on there. All right, so that's our statement of the Pythagorean theorem. So this is step 1 of the lesson. But this is just an example. This is a 3, 4, 5 triangle, which is a really common right triangle. But we want to prove the Pythagorean theorem for triangles in general. So now we're going to use some origami to do a little proof. Okay, so I'm going to stop again while I get